All right. Tell me where we were. Did we talk about this one already? So, increasing, decreasing, no. Constant, decreasing, increasing. So, that is a parabola. Agreed? That's been shifted left 2. Are you starting to see that it's important to be able to make quick sketches of stuff? And are you starting to see that it's important that you understood your transformations last year? Okay? So, this is decreasing, but then increasing. So, from negative infinity to negative 2, include it. Yes, it is decreasing. And then 2 to infinity is increasing. All right. This one. So, x squared, so we don't have any restrictions on parabolas, but we have restrictions on what makes zeros in the bottom. So, do we agree that that is going to factor to x plus 1 and x minus 1? So I know I'm going to have an asymptote at positive 1 and negative 1. Okay? I have a vertical asymptote, a horizontal asymptote at 1 because my degrees are the same. Okay? So, if I don't have a calculator and I'm at home, do I plug in some numbers over here, do I plug in some numbers between here and there, and do I plug in some numbers there to get a picture of this? Yes, okay? If I have access to a graphing calculator, which we're going to have access to for the moment, so I'm going to graph that. We're going to end up with a picture that looks like that. Okay? So, if I transfer that over to my paper, I've got something that looks like that. So, this piece is increasing, this piece is decreasing, and here I have increasing and decreasing. So I am increasing from what? Negative infinity to negative 1, bracket or parenthesis? Parenthesis, because it doesn't include that negative 1 because it's an asymptote, correct? Then I am increasing from negative 1 to 0. Can I include the 0? All right. Then decreasing, and you don't have to write them on opposite sides of the graph, it's just that I ran out of room down there. I am decreasing starting at 0 going to 1, and then I start at 1 again and go to positive infinity. Okay? All right. If I asked you to graph this without that, I would expect that you would need a calculator, okay? But if I cover that up, tell me what I'm graphing here. How do you graph y equals negative 5? It's a horizontal line at negative 5, right? And then is this just a line with a positive slope of 2? So it's going to go up, and then how do you graph y equals 5? Another horizontal line. So is it going to be constant, then increasing, then constant? So from negative infinity to negative 3, and from 2 to infinity it is constant, and then from negative 3 to 2 it would be increasing. Okay? So if I give it to you this way, it's not that big of a deal. If I gave it to you like that, I would also give you a graphing calculator. Okay? And this is just a calculator picture of that. All right, lower bound, upper bound, and bounded. A function f of x is bounded below if there is some number b that is less than or equal to every number in the range of f. Any such number b is called a lower bound. So if something is bounded below, it's going to look something like this. There is a number b that is less than or equal to every other number in the range of that function. So it's on the bottom. It's bounded below. It is a lower bound. Okay? So what do you think bounded above is going to look like? Opposite. So here it is higher than everything. So it is bounded above. It has an upper bound. Then it says it is bounded if it is bounded both above and below. So if I have something that looks like this, I'm going to go that way, then I'm going to come down, then I'm going to go out straight. Do you see I have a top and a bottom? And so because it's bounded above and bounded below, we just say that it is bounded. Then I would have something that looks like this, and I would say it is not bounded because there is no top or there is no bottom. There is no number that everything is above or everything is below. So, bounded below, this is a lower bound. Bounded above, this is an upper bound. Bounded, and then not bounded. Okay? So remember I said the words kind of make sense. So how would we describe this one? Not bounded, because it just keeps going up and it just keeps going down. So not bounded. Whoop, here. Bounded below. It's got a low point, right? Nothing goes lower than that. So bounded below. Bounded above. Got a top and a bottom, right? So this one is bounded. And same thing here, because the arrows are going out. Now, if I curve those arrows and make that one go up and that one go down, then it would become not bounded. But right now, this one is bounded. Okay, local and absolute extrema. A local maximum of a function, f of x, is the value f of c that is greater than or equal to all range values of f on some open interval containing c. If f of c is greater than or equal to is greater than or equal to all range values of f, then f of c is the maximum, or called the absolute maximum value of f. So this would be considered a local maximum. It's a turn in the graph. It has a high point, but is it the absolute highest point on the graph? No. So if that's called a local maximum, this is going to be called a local minimum. But if I come back over here, is this an absolute minimum and an absolute maximum? Yeah. Because there's nothing higher or nothing lower. Okay? So local, when they're in a curve, but the graph keeps going. So this is called a local and a local. Local extrema are often called relative extrema. So this would be called a relative maximum, a relative minimum, a local maximum, a locative minimum, or a relative extrema. Those words are all interchangeable. Okay? So, what would y'all call this? Local, or would it be absolute? Absolute minimum, local maximum, local minimum, or relative maximum, relative minimum. These would be called relative extrema if you put them together, all right? And then it wants you to actually find them. So I want to know where this number actually is, and I want to know where that number actually is, and I want to know where that number actually is. And the only way you will do that is with a calculator. You will not be asked to calculate them. So you would go to this calculator, and you would graph it. And if y'all notice, every time I do a new graph, I start over. I recommend you always do that because you don't carry the junk from the other problems with you that can conflict with what you're trying to do. All right. Well, I need to hit enter first. Oh, we need to get out of all of this. All right. So here's my graph. And if I wanted the local maximum, then I'm going to hit menu. What do I choose next? Analyze, and then maximum. And remember how you have to drag this to the left and hit enter, and drag it to the right and hit enter. And so the local maximum would be at 1.32. It'll be purely calculator. You will not do it by anything but a calculator. Now, because you have multiple, before you didn't have to hover as closely, but on these, because you're trying to find local, you're going to have to hover that on the left and on the right. I mean, you don't got to get like right on top of it, but you can't include the other ones because it won't know which one you want it to find. Okay? All right. Now, here's where you need to take some notes. Symmetry with respect to the y-axis. So this is what I want you to write down. Even function symmetric with respect to y-axis, f of negative x equals f of x. If one of those things is true, all three of those things is true. So if I know that I have an even function, then I know it is symmetric with respect to the y-axis, and I know that f of negative x will equal f of x. Okay? So the question is going to be, is the function odd, even, or neither? So if I look at this graphically, does that graph have symmetry with respect to the y-axis? So I would then know that it is an even function. It is an even function. So if all I'm looking at is the picture, I don't even need the equation. Can I tell it's even because it has symmetry with respect to the y-axis? Okay? If I don't have the picture, then I can say, okay, if I can replace x with negative x and get the same thing, then that's going to make that function even. So if f of x is x squared and I find f of negative x, so what is negative x times negative x? X squared. So do I get the same thing? So that means the function is even, which means the graph would have respect to the y-axis. Okay? So that's even. Odd function. Symmetric with respect to the origin. And f negative x equals the opposite of f of x. So if I distribute a negative through the function, then that would mean that it would be odd and would have symmetry with respect to the origin. Symmetry with respect to the origin. All right, so if I look at it graphically, symmetry with respect to the origin would be equivalent to a 180-degree rotation or a reflection over both x and y. So if I can reflect over x and reflect over y, or turn it 180 degrees, then it has symmetry with respect to the origin, and it is an odd function. Okay? Algebraically, if I replace x with negative x, what is negative x times negative x times negative x? Negative x cubed. So if this is the opposite of what I started with, then it is an odd function, okay? This does not mean inverse. It means opposite. It is the opposite of the original function, okay? All right. You can also have symmetry with respect to the x-axis, but it's not going to be a function, right? That's not a function. If I have symmetry with respect to the x-axis, then it is not a function. And so keep this in mind. Y squared is the sideways parabola, which is not a function. So that's why it's not labeled odd function or even function. It's not a function, period. Okay? Now, can I have a function that is not odd or even? Yes. It just means it's not an odd function, it's not an even function. This is just not even a function, period. So, remember, y squared is a sideways parabola, which is not a function. Every xy would also have to have an x negative y. All right, and the algebraic check for this is not something you're usually going to do. It's more going to be something you recognize graphically. All right, so checking for symmetry. If I want to know whether this is symmetric, if I'm really thinking, I know that's a dang parabola that's been moved up 3, so is it a parent parabola moved up 3? Does it have symmetry with respect to the y-axis? I mean, look, isn't that the picture of this? Okay, so that makes it an even function. If I don't remember that, then I'm going to replace the x, and that is going to give me x squared plus 3. I get the same thing I started with, which makes it even. All right, is this a parabola? Yes. And does it open up? Yes. So it's a function, but do I have a quick visual of that in my mind? Can I just make a quick sketch of that one? No. So I'm going to do g of negative x, which is going to be negative x squared minus 2 negative x minus 2. Negative x times negative x is x squared. Negative 2 times negative x is 2x minus 2. Odd, even, or neither? Neither. It's still a function, but it's not an odd function or an even function. Because to be odd, it has to be the opposite, which means it should be negative, positive, positive. Okay? All right. Any clue what that looks like? Anybody have any visual clue of what that just in their head? No. So algebraically it's going to actually be easier here. So h of negative x would be negative x cubed 4 minus negative x squared. What's negative x times negative x times negative x? Negative x cubed 4 minus x squared, right? Odd, even, or neither? Odd, even, or neither? Okay, what has to be true in order to be odd? Take the function and multiply it by what? A negative 1. So if I take this function and multiply it by a negative 1, which is really negative 1 over 1, won't it only change the sign on the top? Not, because if you change the signs on the top and the bottom, then you're multiplying by a positive 1 instead of a negative 1. And so that's the one that's confusing. Here would I need negative, positive, positive, but it's not a fraction. On a fraction, either the top or the bottom has to be the opposite, but they can't both be the opposite, because then it's the same, it's just factoring out 2 negative 1s, which cancels it out. Okay? Alright, so that's checking for symmetry. Horizontal and vertical asymptotes. We've talked about them. What makes the vertical? What makes the 0 on? the bottom unless it's a log, which automatically has one, correct? Okay. Horizontal. What makes the horizontal? The degrees at the top and the bottom, unless it's exponential, which automatically has a horizontal. So, we have this fancy notation, limit, limit. All right. So, that is no different than what you were asked to do last year. You just didn't write it that way, okay? So, let's go back to a graph that looks like this. Do y'all remember us asking you what is the right behavior and what is the left behavior? So, to the right, this graph is going up. And to the left, this graph is going down. And we would write this. As x approaches positive infinity, f of x approaches positive infinity. To the right, the graph is going up. And as x approaches negative infinity, f of x approaches negative infinity. To the left, the graph is going down. Well, we are writing the same thing. We're just using this notation of function, of limit, So I'm going to write the word limit. This goes under the word limit, and they're not going to put a positive for positive, so it's just going to say as x approaches infinity, and then I'm going to say f of x equals infinity. So to the right, this graph is going up, and then to the left, this graph is going down. So, is it the same notation, just written in a different, and then instead of this arrow, you put an equal sign. Instead of the arrow, you put an equal sign. So, these are referred to as your end behavior. What is it doing way out to the right and way out to the left? All right, way out to the right and way out to the left. Now, if I draw an asymptote in here, then not only do I have end behavior, I have the behavior at my asymptote. I have the behavior at my asymptote. All right, so way out here to the right, to the left, this graph is getting closer and closer to what? 0. So the limit of f of x to the left is 0. Right? Agreed? Is it also getting 0 to the right? The limit to the right is 0. So wake up, y'all with me? Okay. So this is just telling me what it's doing way out to the left and way out to the right. Here it was kept going up and here it kept going down, but here it's actually approaching 0. Okay? But we also were going to talk about the behavior at this asymptote. So as I come into that asymptote, and let's just say it's at positive 1, so as I am coming to 1 from the left, so I'm going to put a little negative sign there. As I am approaching 1 from the left, this graph is doing what? Going down. So what am I going to put here? F of x equals negative infinity. And as I approach this graph from the right, it is doing what? Going up. So here, positive infinity is left and right. Asymptote, little means from the left, plus means from the right. All right? And we'll touch on that a little bit more tomorrow. You should be able to identify the asymptote. Hang on, don't go anywhere. Tonight for homework, in that homework packet, look really quickly and I'll be fast. You're going to turn to this bottom page where it says section 1.2, and you're going to, it's the third page, and it's going to be 1 through 61 odd. 1 through 61 odd. The 1.2, 1 through 61 odd. Yes. You should have a packet if you've been in PreCal. It's the same packet. Yes. Did you not go to her class? Oh, well, thanks.